Okay, hi everyone. Today we are looking at section 5.4, which is differentiation rules for exponential functions. So what we're going to do today is we're just going to combine derivatives of exponentials with rules that we learned earlier, like product rule, quotient rule, chain rule, etc. So I just have here, we call the chain rule. If f at x is equal to a to the exponent g at x, then the derivative is equal to the original function times ln of the base times the derivative of the exponent. All right, so first one is y equals e to the x squared. Okay, so the derivative, which we can again write as dy by dx, or y prime, is equal to, so it's the original function, e to the x squared, times ln of the base, but ln e is just 1, so we have to write that, times the derivative of the exponent, which is 2x. And oftentimes we write it with the 2x in front. So 2x e to the x squared. All right, good. So next one, so dy by dx is equal to, the 100 is a constant out front. It's not affected by the t over 5, so we keep the constant out front. And we multiply it by the derivative of 2t over 5. Okay, which is the original function, which is 2 to the t over 5 times ln 2, ln of the base, times the derivative of the exponent, which is 1 over 5. Okay, now in exact form here, what we're going to do is we're going to bring the 1 over 5 out front. Okay, so we have 100 times 1 over 5, which is 20. And then put the ln 2 times 2 to the t over 5. And that's a good final answer in exact form. Okay, and next one, notice here we have the product of two functions. Okay, so the derivative is equal to f prime g plus g prime f. Okay, so what we have here is derivative of f prime is the original, which is e to the 2x times 2 times g, which is sine x. And I'll just drop down here, plus derivative of g is cosine x times e to the 2x. Okay, and then just simplify this a little bit. We can actually write it in factored form. Again, factored form is nice, especially when we're finding local max or mins. So I can factor out an e to the 2x, and we're left with 2 sine x plus cosine x. Okay, and that's how I prefer the answers. Nice. Okay, next one. So y prime, or dy by dx, is equal to, okay, we have the sum of two functions. So the derivative of the sum is the sum of the derivatives. The first one is going to be 8x plus, and then I'll just skip with derivative of this, which is 3 e to the 3x. Okay, good. And then the next one here, y prime is equal to negative 4. Derivative of sine is cosine e to the sine x. All right. Okay, so next one, determine any local extrema of the function y equals e to the x over x. Okay, so remember, for a local extrema, the derivative is equal to 0. Okay, and we also have a quotient here. So recall the quotient is equal to f prime g minus g prime f over g squared. Okay, so we'll go back over here. Y prime is equal to f prime is just e to the x times g minus g prime, which is 1 times f e to the x all over x squared. Okay, and now we will simplify this a little bit. So we're going to factor out an e to the x, and we're left with x minus 1 over x squared. Okay, and now we want to set this equal to 0. Okay, so for this to equal 0, remember the denominator does not affect it at all, so we just ignore it. We look at the numerator, so we have possibilities. So either e to the x is 0 or x minus 1 is 0. E to the x is an exponential function, will never be 0, so we don't have to worry about that. So we just worry about the x minus 1, and that'll be 0 when x equals 1. Okay, so when x equals 1, it's our critical number. To get our critical point, we're going to plug it into the equation. So we have y is equal to e, because you have e to the 1 over 1, which is just e. So our critical point is 1 comma e. Now we want to determine if this is a max or a min. Okay, so to do so, we're going to do we're going to use the first derivative. So we're going to evaluate the first derivative, okay, at a number less than 1 and a number greater than 1. Okay, so here's our x is 1. So we can say 0 and we can say 10. It doesn't matter what numbers you pick, right? So let's plug in 0. No, we're not going to plug in 0 because we have a denominator 0. Let's go negative 10. Okay, so if we plug in negative 10, okay, e to the negative 10 is still a positive number divided by a negative number. So the first derivative is negative. And if we plug in positive 10, the first derivative is a positive number. So that means that we're going from a decrease, right, to an increase, which means that 1 comma e is a local min. And that's it. And there's your work for today.